All right, let's do solutions of the chapter Solutions, Exemplar. First question, which of the following units is useful in relating concentration of solution with its vapor pressure? P proportional to concentration. Well, where have you seen this? First thing to see here is parts per million and mass percentage are similar. Parts per million can be mass percentage, weight by volume, or volume by volume, all the same. Okay, so both of these options are same, and since this is just one correct, you can eliminate them. So you got to decide between molality and mole fraction. The idea here is that delta P by P naught is equal to what? X, which is mole fraction itself. And there you go. So we are relating change in vapor pressure to mole fraction. So this one should be the answer right over here. This is a quick question, shouldn't take more than 10-15 seconds to do in an actual exam. On dissolving sugar and water at room temperature, solution feels cool to touch. अच्छा, ठंडा हो गया, ठीक है, which means endothermic है reaction. I'm going to write that down. Endothermic, without you looking at the options. Okay, does that matter? We'll see. Which of the following cases dissolution of sugar will be most rapid? Yeah, there you go. If the process is endothermic and I provide heat to it, then it happens quickly. ठीक है? Okay. So hot water. Oh, okay. Let's cut out the cold water options. Also, powdered sugar versus sugar crystals. Yeah, more surface area. Nice question. Nice question. Makes you think. At equilibrium, the rate of dissolution of solid solute in a volatile liquid solvent is. Okay, equilibrium. Same ही तो होना चाहिए ना? I don't think this is complicated. Yeah, okay. Next one. A beaker contains a solution of substance A. Precipitation of substance A takes place when small amount of A is added to the solution. Okay, this was again a definition kind of question. Okay, you've got some sort of a solution and thoda sa मैं अगर add करूँ, then there is a precipitate that gets formed, even a little bit. So what is this? Is this saturated, supersaturated, unsaturated, or concentrated? Concentrated is a dummy option. Let's kick that out of here. Okay. So if you have a doubt, it's probably going to be between option 1 and 2. Is it saturated? Is it supersaturated? See, if it is saturated, then you say that ठीक है, it's that level that is the exact amount of solute needed. You can't dissolve any more. Okay. But if a precipitate forms right away, that is said to be supersaturated. This is just a definition thing. Okay. This is the answer to this. Let's move on to the next one. Maximum amount of a solid solute that can be dissolved in a specified amount of given liquid solvent does not depend on. Okay. Temperature तो पे depend करता ही है. So let's cross that out. Okay. Nature of solute पे definitely depend करता है. Pressure. If it was a gas, then sure. But solids, I think that doesn't matter. Nature of solvent, yeah, absolutely. It does depend, yeah. Question is does not. Okay, next one. Low concentration of oxygen in the blood and tissues of people living at high altitude. Well, as you go higher up, what changes? Pressure falls. So अगर pressure कम हो गया, तो कम gas dissolve हो सकती है. What kind of pressure? I'm talking about atmospheric pressure. That's what is reducing. So I think it's just this. Low atmospheric pressure. But do you think temperature has to do anything with this? Well, you could argue कि जब पहाड़ में जाते हो ठंडक हो जाती है, sure, but that's not what's being discussed here. Okay, the answer to this one is just atmospheric pressure, low atmospheric pressure. देखो हमारा temperature, body temperature of humans is the same. It's not going to change. We feel cold because outside temperature is lower, but the body temperature is maintained. Yeah, it needs to be that perfect temperature for it to operate properly. The body itself. Don't get confused. Considering the formation, breaking, and strength of hydrogen bond, predict which of the following mixtures will show a positive deviation from Raoult's law. पहली चीज positive deviation क्या बोला है? We are talking about pressure, okay, not temperature. And जब बहुत ज़्यादा positive deviation हो गया, then you get a minimum boiling point azeotrope. There we are talking about temperature, but here we are talking about pressure being higher than normal. Why would pressure be higher? Think about it. Pressure higher मतलब कि things don't mix. So A-B interactions are weaker than AA and BB interactions. That's what we're looking at. Okay. So maybe AA-BB में कुछ hydrogen bonding और कुछ ना कुछ हो. Okay. That's the theory behind it. Okay. Considering formation, breaking. हाँ ठीक है. Hydrogen bond की बात हो रही है. Okay, great. So methanol and acetone. right away I feel that that should be the answer, क्योंकि methanol में है CH3OH, मतलब hydrogen bonding exist करती है, और मैं उसको तोड़ रहा हूँ by adding acetone in it, chloroform acetone, और this is a classic example of the उल्टा वाला चीज़, right? NCERT में दिया हुआ है. This should be the answer. Nitric acid water, again, this is an azeotrope, man, like a, yeah. No, we're not talking about this one. And this shows a negative deviation for sure. Phenyl, yeah, okay, easy one. One is the answer to this one. Phenylalanine, alanine, what will happen? OH and NH2, right? There will be interactions, good interactions. So, answer to this is 1 again. Colligative properties depend on nature of solute particles. No, that's the point. It's just the number, right? Please don't get confused by this. I know students are tempted to mark this. It's not. It's just the number. That's the whole point of colligative properties. Let's mark the others off. Okay, let's read through them if you want. Physical property of solute particles drawn solution. Nah. Nature of solute. No. Bilkul bhi nahi. Just the number of solute particles. That is the whole point of colligative properties. You can check out the videos that I've made on Khan Academy recently on this, on the whole solute, on solutions, and it's done in quite some detail. Which of the following aqueous solutions should have the highest boiling point? Highest boiling point, okay? So this has to do with elevation of boiling point, right? Q, क्योंकि I'm adding solute to it. What kind of solute? Non-volatile solute. Okay, cool. Delta TB is KB times M. Add an I there because we are talking about, there are no brackets here, I've just put that here. We're talking about, well, things that dissociate and produce more number of particles than they should, right? All of these are strong electrolytes, NaOH, 2 ions per molecule of NaOH, Na2SO4, 3 ions, NH4NO3, 2 ions, KNO3 again 2. So according to me, the answer is right over here, Na2SO4. Why? Because each molecule, if you can't see it already, we'll write that down slowly, gives me 2 Na plus ions plus 1 SO4 2 minus ion, right? What is I? It's, well, expected moles divided by actual moles. Well, not actual, calculated moles. Ulta likh diya na? Yeah. It's actual moles by calculated moles. That's the definition of I, right? And even if you don't remember all of that, you can clearly see that this has more solute particles. So this is going to have a higher I value for the same molality. And all of them are, molarity is the same, so let's assume molality also is going to be the same. So delta TB will be the highest in case of 2. Okay. What is the unit of ebuloscopic constant? पहली बात, ये ebuloscopic constant होता क्या भला है? Well, right here, this KB is ebuloscopic constant. बढ़िया सा नाम. If you look at this, KB should have the units of delta TB by M. मतलब temperature ऊपर होना चाहिए, molality नीचे होनी चाहिए. This is mole per क्या? Kilogram of solvent, right? So temperature, then kilogram, and then mole. That's it, right? Okay. So Kelvin, kg per mole. That's my go-to answer, I think. We'll figure out the option. That's not that big a deal. Looks like पहला वाला ही सही है. Kelvin, kilogram per mole, or Kelvin, molality inverse. Yeah, there you go. Beautiful, isn't it? Okay, next one. In comparison to a 0.01 molar solution of glucose, the depression and freezing point, इसका क्या होगा? Same twice, 3 times. Oh, this is easy. You don't have to put too much effort into this, because again, this is an I idea, right? Delta TF is equal to I times KF times M. Higher the value of I, higher, well, the depression and freezing point. In this case, I is equal to 1. In this case, I is not equal to 1. What is I going to be? 2 chlorine, 1 magnesium. So I is 3. It's going to be 3 times. Simple enough? Yeah? Alright, next one. An unripe mango placed in a concentrated salt solution to prepare pickle. Oh, mango pickle. Yeah, that's very tasty. Shrivels. Okay. Again, I've done this theory in the Byju's Wale sessions, or also on Khan Academy recently. I like this. Osmosis is a pretty cool topic. So, unripe mango is placed in a concentrated salt solution. what's the difference here? Concentrated salt, मतलब कि its pi value is going to be pretty high. Why? What was pi? It was I times C times R times T. Okay, so this I value is going to be salt, मतलब NaCl, right? It's going to be 2 and concentrate whatever etc etc कुछ होगा. And well, mango के अंदर जो पानी है, or is water, let's assume it does have something in it, right? It's not just water, it's got sugar, it's got something else. So there I feel the pi value should be, what, is it higher, is it lower? This is getting complicated. Okay, let's take a step back. It's saying that it shrivels. If it shrivels, that means water flows from mango to the concentrated solution. Yeah, concentrated solution. Okay, this is direction of water flow. Oh, and hold on, there is a semi-permeable membrane. Yeah, I'm going to try and draw it. Yeah, I'm not that great at drawing stuff. So this mango peel now is your semi-permeable membrane. मतलब well, ये मैंगो का जो ऑसम अंदर वाली चीज़ें हैं, द फ्लैश, उसको तो बाहर जाने देता नहीं है. वॉट एवर सोल्यूट, और इनफैक्ट नमक को भी अंदर नहीं आने देता. दैट विल बी हॉरिबल, राइट? नमक अंदर चला गया तो, बट पानी मैंगो से बाहर चला जाता है. यही तो कॉन्सेप्ट है सेमी परमेबल मेम्ब्रेन का. अगर मैं इस टाइप का सेटअप लूँ जहाँ पे सेमी परमेबल मेम्ब्रेन मैंने डाल दी, अभी इस तरफ मैंने डाल दिया सॉल्ट सॉल्यूशन और इस तरफ मैंने डाल दिया प्योर वाटर. किस डायरेक्शन में होगा पानी का फ्लो? इस डायरेक्शन में, क्योंकि सेमी परमेबल मेम्ब्रेन की वजह से नो सोल्यूट फ्लो, राइट? मतलब सॉल्ट फ्लो नहीं कर सकता है, बट पानी फ्लो कर सकता है. अब इस डायरेक्शन में क्यों होगा फ्लो? बिकॉज यहाँ पे पानी की कॉन्सेंट्रेशन है ज़्यादा. आई नो इट्स वियर्ड टू से पानी की कॉन्सेंट्रेशन, बट x ऑफ वाटर इज बेसिकली इक्वल टू 1 एंड इन दिस केस x ऑफ वाटर इज लोअर देन 1, राइट? तो पानी की कॉन्सेंट्रेशन लेफ्ट में ज़्यादा है, राइट में कम है, तो इसीलिए पानी का फाइनल लेवल थोड़ा सा बदल जाता है. इसको मैं इरेज कर देता हूँ. आई होप पूरा ना इरेज हो जाए. 1 सेकेंड, क्राफ्टिली इरेज जस्ट दोस टाइनी बिट्स. एंड इसके कारण यहाँ नीचे, यहाँ पे थोड़ा ऊपर हो गया, राइट? सेमी परमेबल मेम्ब्रेन इज स्टिल हियर. ओके, अब ये सब थियोरी मैंने क्यों की? क्योंकि इस प्रोसेस को हम लोग बोलते हैं ऑस्मोसिस. तो यहाँ पे भी ऑस्मोसिस ही हो रहा है, रिवर्स ऑस्मोसिस नहीं हो रहा है. आई विल टेल यू व्हाट रिवर्स ऑस्मोसिस वेरी क्विकली. इसको अगर मैं उल्टे डायरेक्शन में करूँ, विच मीन्स कि आई अप्लाई अ प्रेशर इक्वल टू पाई इन दिस ऑपोजिट डायरेक्शन, इस डायरेक्शन में अगर मैं पाई यहाँ पे लगाऊं, राइट, तब आई कैन स्टॉप दिस ऑस्मोसिस, राइट? उसी से हम लोग पाई डिराइव करते हैं. और इफ पी इज ग्रेटर देन पाई, देन यू से रिवर्स ऑस्मोसिस हैपेंस. ओके, सो वी आर नॉट टॉकिंग अबाउट इट, ये सब हम लोग बात नहीं कर रहे हैं. हो, ये तो पूरा हमने थियोरी रिवाइज कर ली. खैर, सिंपल आंसर है कि जस्ट लूजेज वाटर ड्यू टू ऑस्मोसिस. क्यों? क्योंकि यार जो सॉल्ट कॉन्सेंट्रेशन है, कॉन्सेंट्रेटेड सॉल्ट, अगला दूसरा कलर यूज़ करता हूँ, बहुत ज़्यादा ब्लू लिख लिया ना हमने. कौन सा कलर यूज़ करें? ऑरेंज. ओके, लेट्स डू ऑरेंज. कॉन्सेंट्रेटेड सॉल्ट इस तरफ है एंड मैंगो वाला पानी एंड ऑल ऑफ दैट इज ऑन दिस साइड. दिस इज व्हाट वी आर सेइंग. आई नो इट्स नॉट प्योर वाटर, मैंगो में भी शुगर वगैरह है, बट कॉन्सेंट्रेटेड सॉल्ट मतलब उसका जो भी कॉन्सेंट्रेशन इज हायर देन व्हाट एवर देयर इन मैंगो. दैट्स व्हाट्स हैपनिंग हियर. ये क्वेश्चन कुड गेट ट्रिकी अगर आप इसमें ज़्यादा दिमाग लगाओ. इफ़ यू डोंट, इफ यू जस्ट गो विद द बेसिक्स, यू आंसर इट, शुड आंसर इट 10 सेकंड, बट इट कुड बी अ टाइम सिंक, जैसे हमने भी देखा. काफ़ी डिस्कशन कर सकते हैं इस पर. अगला सवाल. एट अ गिवन टेम्परेचर, ऑस्मोटिक प्रेशर ऑफ अ कॉन्सेंट्रेटेड सोल्यूशन ऑफ सब्सटेंस. एक टेम्परेचर पे ऑस्मोटिक प्रेशर, हाँ, कॉन्सेंट्रेटेड सोल्यूशन का ज़्यादा ही होना चाहिए. या वी हैव जस्ट डन ऑल ऑफ दिस राम कहानी, सो शुड बी ओके. शुड बी हायर देन दैट ऑफ अ डाइल्यूट सोल्यूशन. या व्हाई? बिकॉज पाई इज ICRT, ऊपर ही लिखा था, राइट? That's it. You don't have to look at the other options. We just did this. Which of the following statements is false? Two different solutions of sucrose of same molality prepared in different solvents will have the same depression and freezing point. सोचने दो. Two different solutions, काफ़ी लिखा है ना, of sucrose of same molality. Yeah, अगर molality same है, solution जो भी हो, क्या फ़र्क पड़ता है? Number of particles. So this is correct. हमको निकालना है false वाला, right? तो let's mark it off. बट एक मिनट सोचने दो. टू डिफरेंट सॉल्यूशंस ऑफ सेम मोलैरिटी प्रिपेयर इन डिफरेंट. ओ अरे, डिफरेंट सॉल्वेंट, ये तो ब्लंडर हो गया. देखो जल्दी जल्दी पढ़ने में. डिफरेंट सॉल्वेंट्स, नो, दे विल नॉट हैव अ सेम डिप्रेशन एंड फ्रीजिंग पॉइंट. व्हाई? बिकॉज KF इज सॉल्वेंट डिपेंडेंट. KF solvent dependent, इसीलिए ये वाला हो गया गलत. Hence the right answer. Moral of story, जल्दी जल्दी चीज़ें नहीं करनी चाहिए. Let's look at the other options. The osmotic pressure of a solution is given by the equation pi equal to CRT, where C, yeah, sure. I mean, I like to put an I over here, right, to make this correct. But ठीक है, because we've got the first one as false, then this one can be true. But strictly speaking, I should want to put that I over there. But जब आप पहली बार pi के बारे में पढ़ते हो osmotic pressure, we don't put the I. We put that later on, right? Abnormal molar masses, etc. वाला चीज़. Decreasing order of osmotic pressure for etc. 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 is this. Okay, yeah, sure, makes sense. Iska I value is equal to 3. This is 2. This is 1, and this is 1 as well. Hold on, this is not 1. This is 1 point alpha. Shouldn't do that, right? This is basically 1 plus alpha. What? What is 1 plus alpha? Oh my god. All right, this is interesting, right? हम लोग इसको, मैंने सेम चीज़ 2 बार लिख दी. ये थोड़ा कॉम्प्लिकेटेड है एक्चुअली, राइट. आई थॉट I'd get away with this easily, बट ये वाला थोड़ा कॉम्प्लिकेटेड है. देखो, NCERT में 2 चीज़ें दी हैं. जनरली एवरीवेयर इन लाइफ वी हैव सीन दैट दिस हैपन्स. एसिटिक एसिड है, मतलब कि पार्शियल डिसोसिएट करता है, विच मीन्स इफ आई स्टार्ट विथ C at equilibrium, I have seen to 1 minus alpha, I have C alpha and C alpha. So total particles at equilibrium seen to 1 plus alpha. Now this gives me I value to be equal to 1 plus alpha. ठीक है, कहानी खत्म. But NCERT में ये भी लिखा है, this is there in NCERT, that this dimerizes. That complicates life a little bit, doesn't it? Because in this case, if you do the same जो हमने यहाँ पे किया है, ये सब चीज़ें, this is getting a little bit messy, but ठीक है, इसके ऊपर लिख देते हैं, क्या फ़र्क पड़ता है. 4th ऑप्शन आप पढ़ लेंगे, it's not like you can't read it. If you do this, if I take this to be C, right, and I take this to be C alpha, then ये हो जाएगा C alpha by 2. फिर से ठीक से लिखते हैं, C into 1 minus alpha. अगर मैं इसको लिखूँ तो इसका चेक करने का क्या तरीका है. अगर alpha is equal to 1, then left hand side हो जाएगा 0, right hand side हो जाएगा half of what it was, right? So just check that if this is fine. अगर आपको ये ठीक लगता है, तब इसमें क्या हो जाएगा, then this becomes total moles at equilibrium becomes C into 1 minus alpha by 2. अब यार I will be equal to 1 minus alpha by 2, so I is less than 1, and you're like, bro, फिर ये तो गलत हो गया है ना. तो in that case CSCCO should be on this side because it's less than 1. But NCERT is amazing and beautiful, so we are left with this conundrum जहाँ पे हमको इस वाले को इग्नोर करना पड़ेगा इस सवाल के लिए. बट मैंने डिटेल में इसलिए ये किया, लगता है थियोरी का ही रिविजन हो रहा है, क्योंकि यू नीड टू नो कि अगर डायमराइज हो रहा है तब ये हो रहा है. बट इन द यूजुअल वे ऑफ थिंग्स, द यूजुअल वे वी डू थिंग्स, दिस इज व्हाट मेक्स सेंस. या दैट you've got the whole acid, weak acid just dissociating. That is what we're assuming. Weak acid dissociating. I have a feeling no one's going to explain this question in this much detail. We have all the time in life and we want to do things properly. So हम लोग करेंगे. According to Raoult's law, the vapor pressure exerted by a volatile component of solution is directly proportional to its mole fraction in solution. Wow, difficult question, huh? ये वाला सच है. चलो, values of Van 't Hoff factors. यार, this bugs me. It should be Van space this. That's what Wikipedia says. Anyway, Van 't Hoff factors for KCL इन सब का दिया हुआ है. Wow, 2, 2, 3.